Have you ever wondered how critical internet services stay online even when something breaks, preventing frustrating outages and keeping our digital world connected? Redundant physical components in networks are duplicate pieces of hardware, like routers, switches, power supplies, or cables, specifically designed to take over operations immediately if an active component fails. Their primary purpose is to ensure continuous service availability and prevent single points of failure within a network infrastructure. This strategy is fundamental to building highly reliable and resilient systems. The core mechanism behind this strategy is fault tolerance, which is the ability of a system to continue operating without interruption even if one or more of its components experience failure. Networks achieve this by employing various redundancy designs. For instance, in a process known as active-passive redundancy, one component handles traffic while an identical backup remains idle, ready to assume control. Another common approach is active-active redundancy, where multiple components simultaneously process traffic, and if one fails, the remaining active components pick up the extra load. This proactive duplication minimizes downtime because the backup systems are already in place and often pre-configured, allowing for seamless transition without manual intervention. It is a critical layer of defense against unexpected hardware malfunctions, environmental incidents, or even human error. Implementing redundant physical components involves careful planning and deployment across different layers of the network. This includes duplicating core devices like network switches and routers, using multiple power supply units in servers, and deploying redundant internet service provider connections with diverse physical paths. Network engineers also consider redundant cabling, often using multiple physical pathways for data to reach its destination. For example, a single server might have two network interface cards connected to two separate switches, ensuring connectivity even if one switch fails. This systematic duplication at each critical point ensures a robust and resilient network architecture. A key concept here is the mean time between failures, or MTBF, which measures the predicted elapsed time between inherent failures of a system during operation. By introducing redundant components, the system's overall MTBF can be significantly extended, improving overall reliability. Another important aspect is path redundancy, where data can travel along multiple distinct routes from source to destination. If one path becomes unavailable, traffic can automatically reroute via an alternative path, often with minimal disruption. This careful planning goes beyond just having a backup and considers the entire flow of information. Understanding redundant physical components reveals the sophisticated engineering behind the always-on internet. It is a commitment to uninterrupted service, ensuring that our digital interactions, from simple web browsing to complex data transfers, remains stable and accessible. This foundational practice of building in multiple fail-safe mechanisms is what makes our modern interconnected world function reliably day after day.
If you love understanding how the web works, like, subscribe, and stay connected with us.